Hello, everyone. Today's training video is going to be about A2L refrigerants in commercial refrigeration. We're going to be talking mostly about R454A and R454C. To set up our agenda, first we're going to go over regulations, specifically the AIM Act, what that means to you. We're going to talk a little bit about retrofitting for the future, what we're going to do with those 404A systems out there. And then what's an HFO? We're going to talk about flammability testing, that's referred to as ASHRAE Standard 34, and then understanding A2O refrigerants and their applications with R454A and R454C. We're going to look at mitigation strategies, and then we're going to look at trucks, tanks, and tools. We're also going to discuss acronym definitions and why it matters, resources, and then the Optian training page. Let's look at what ODP versus GWP means. First of all, we know ODP is ozone depletion. That was back when our Montreal Protocol, when we got our EPA cards and what have you in 1987. Those are refrigerants that had chlorine in them, and they started to notice a hole in the ozone. A fun fact, the ozone hole has actually gotten a little smaller, a lot smaller. In fact, if you were to look at my little red laser dot there, that's about the size of the hole in the ozone now. In fact, they've projected that it would be closed by the year 2060 something. So again, ozone depletion potential for those refrigerants was a phase out. Okay. In other words, you cannot make any new version of it. All right. We can buy it reclaimed like R22, but we can't make any new. All right. And then let's look at GWP over here on the side. That's when we refer to the Kigali Amendment. Now, the Kigali Amendment was simply an amendment off of the Montreal Protocol because the Montreal Protocol only talked about ozone depletion potential, refrigerants like R12 and R22 and those kind of things. This is focused on HFCs, and the Montreal Protocol had no mention of HFCs. Okay. So basically, the difference here is I think of it, this is like the atmosphere is the Earth's sunblock, if you will. When we look at the GWP, basically the sun is radiant heat. We know that. And the way it's always worked since we've been studying it, that radiant heat, how does radiant heat work? It doesn't heat the air, it doesn't heat vapor. It only heats mass, whatever it hits to, whether it's your body, that table, a chair, something like that. So when it hits the earth, since the beginning of time that we've recorded this, it absorbs most of the heat, but not all of the heat. Some of that heat bounces off the earth and goes back out through the atmosphere. Well, this atmosphere bubble, if you will, is getting thicker and thicker, and it's now trapping some temperature in there. So this is the reason they're trying to find, or they found refrigerants that have a lower GWP, which simply means they break up faster in the atmosphere. And that's what the goal is. This is not a phase out. In some areas, it's pretty aggressive, but it's a phase down. Eventually, we will buy reclaimed refrigerant with our HFCs, just like we do R22 today. But we're moving to a lower GWP refrigerant, and we have a bunch of items to talk about today. So why are we doing this? The EPA to produce the following under the AIM Act. The AIM Act is simply the government give the EPA their authority to set these ground rules, okay? And the AIM Act to me is like a three-step or a three-leg operation. The first step is allocations, okay? And that went into effect in 2021. And what that basically means is how much virgin HFCs you can make, all right? And it's based on your GWP. All right. It's not weight or gallons. And I'll step that through all these items with you one by one. Okay. It's a CO2 equivalent of limitations for producers and importers. Okay. So that's 2021. That was the first phase. The technology transition rule went into effect October 2019, I believe. And this talks about applications. GWP limitations by equipment applications, and whether it's a condenser for refrigeration, whether it's a split system for air conditioning, it has all these different GWP levels that you can't go over or you're in violation. And then the third step is the refrigerant management programs. Its use of reclaimed refrigerants, leak rates, and leak detection. So I'm going to talk about all of these one by one. So the first step, the allocations. In 2021, that was our baseline. All right. And this was a bipartisan bill, that went into effect. It stepped down 10% in 2022. And again, keep in mind, this whole step down is a phase down, not a phase out. But you can see in some areas it's kind of aggressive. Okay. So, but the other thing I want to mention here is too, it's not just refrigerants, and it's not just one refrigerant. It's not 410A or anything like that. It's based on HFCs, and HFCs can come in a lot of different ways. Inhalers, solvents, fire extinguishers, foaming agents for insulation, those kind of things. They all have HFCs in it. So the higher the HFCs, the less you're going to be able to make it. So each manufacturer, like Chemours, has a certain allocation to them, which means they've got so much in their bucket, and once that bucket gets empty, that's all they can sell or manufacture as a virgin. This is all virgin. Okay, so we started out at 100% in 2021. We stepped down. The first step was 10% in 2022, 30% in 2024, and another 30% in 2029. And then we go down to 10% in 2034, and then down to 5 more percent. The goal is to be down to 15%, okay, by the year 2036 compared to where we started at. Okay. Now, one would think, how are we going to do this? How are we going to get down all the way down to only 15%? Well, you're going to see as we move along that the new refrigerants have a much, much lower GWP. Now, the second step, the technology transition rule, is GWP limits. But I want to start here at this blue line. Compliance is determined by 3 factors. Number one, the application, okay, whether it's a residential AC, remote condensing unit, supermarket systems. And then 2, the GWP limit. What is the peak? What's the most you can have in that system that the EPA or the AIM Act has decided? And then 3, the effective date. This went into effect in 2025. This will go into effect in 2026. And this will go into effect in 2027. So let's walk through them. I'm going to start over to the left side. Starting in January 1st of 2025, which is this year, residential AC can have no greater than 700 GWP. Ice rinks can have no greater than 700 GWP. Comfort cooling, no greater than 700 GWP. All right, moving next year, January 1st of 2026, remote condensing units over 200 pounds can have no greater than 150 GWP. Remote condensing units with less than can have more, up to 300 GWP. And then VRF systems will then be 700 as it was before over here. Okay. So when we look at 700, basically what this is telling us over here at the residential AC, by the way, that means we can't produce after the first of this year any R410A equipment anymore. Okay. We can't produce it. We do have a sell through date until 2026, but we can't manufacture that because this 700 GWP is the max, and 410A is right around 2088, somewhere thereabouts. So the 2 big players right now is R454B and R32. Now over here at the end, it's pretty much identical over here to the remote condensing units. However, we're talking about supermarket systems. Now they took this in steps because they didn't want to do it all at one time and cause a lot of confusion. So the easiest place to start was your residential, like commercial stuff. Okay. And now we go into January 1st of 2027. We're talking about supermarkets, anything over 200 pounds, 150 GWP. Supermarket systems below 200 pounds, we're going to allow 300 GWP. And then air conditioning for data centers will be 700 GWP. So really, it's the more refrigerant you have in the system, the longer the line sets, if you will, the more opportunity for a leak or to blow the charge, the less GWP you're going to have in the refrigerant that's going to be allowed. Okay. So it's got to be a low GWP for those really long line sets or lots of pounds of refrigerant. There is a QR code if you want to scan this up here for the EPA full rule fact sheet. Now, the third step, the key points are minimize releases. It bans the intentional or careless release of HFCs during the appliance maintenance and disposal. It maximizes reclamation and reuse. It sets standards for recovering, recycling, and reclaiming refrigerants while limiting the use of virgin refrigerant in reclaimed blends. Strengthens leak repair practices. What that means is it requires automated leak detection when possible, quick repairs for significant leaks, and regular monitoring to reduce emissions. Ensure technician and consumer safety. What does that mean? The law mandates training and certification for technicians, like we've always had in our 608. Outlines proper handling and labeling, and establishes protocols for safe installation and disposal. Next, improving reporting and record keeping. This means requires commercial and industrial facility operators as well as certified reclaimers to track and report the quantities of refrigerant recovered, recycled, or imported. All of this will help the EPA monitor compliance with the reclamation and emissions reduction goals. Obligate equipment owners and reclaimers to track quantities reclaimed, recycled, and improved, and report. Then information to the EPA, helping the agency verify compliance with the phase down and reclamation targets. Now, the obligation equipment owners and reclaimers to track quantities reclaimed, recycled, and imported and report that information again to the EPA, helping the agency verify compliance with the phase down and reclamation targets. Now, I'm going to bring these three legs together, if you will. This is the first step, that allocation. The second part is the transition, if you will. And this just shows a comparison from 404A, a very commonly used refrigerant out there for medium and low temp. The GWP, if you didn't know, is 3922. So it's basically somewhere around 4,000 compared to our 454A, the GWP at 238. And this is for systems less than 200 pounds we talked about earlier. Remember, the peak was 300 GWP, 300 or less, okay? And then thirdly, is going to be your reclamation part. That's what we're going to see right here. Once we start to phase these down, not out, but down, we'll start relying on reclaimed refrigerant. Right now, the way it sets is the statistics show that out of all the refrigerant sold, we only reclaim about 2% of it. Okay, so this is going to be very important to keep the price down and keep that refrigerant around because, like I said, this blue line refers to virgin refrigerant or virgin HFCs, if you will. Okay, so allocations, importers and manufacturers, technology transition. This affects the OEM equipment designs, and then refrigerant management is every stakeholder from technicians to manufacturers. Retrofitting. What are we going to do with all these systems out there? We're going to look at 449A and 513A and where they apply. So this is a map, and I'll start at the top here. This will be low and medium temperatures, refrigeration chillers, air conditioning chillers, and the refrigeration air conditioning chillers, and then air conditioning chillers and heat pumps. The green boxes indicate what can be retrofitted for these gases up above, okay, with the higher GWPs. And the blue boxes indicate what you'll see in the new A2L equipment moving forward, okay? So for refrigerants like R22 in medium and low temp, GWP of 1810, we're going to be looking at R449A or R448A, okay? And that has a GWP of 1282. So when you compare that to refrigerants like 404A, that's a big difference even on the retrofit gas, okay? When we go into the new equipment, it's even going to get lesser, okay? So this is for your refrigerant systems with less than 200 pounds. It has to be less than 300 GWP. That'll be your 454A. On applications with more than 200 pounds that have to have less than 150, that'll be your 454C. 454C was made purposely for that reason, anything over 200 pounds. 454A was the first design. This was after the EPA set the guidelines for over 200 pounds, okay? And this will only be used in new equipment. Anything that's in a blue box will not be put into any of these existing systems, pardon me. They're not designed for A2L equipment. Over here, air conditioning chillers, these are R22 applications. We're going to be able to use 407C, new 22 or 422D, and then 417A would be Mo 99, and those will take the place and still replace those air conditioning chillers that might have R22 in them. Okay. For the new equipment, 454C, that's a GWP again of 146. Over here, we're looking at the replacement 134A, typically found in medium temp applications and also air conditioners. Okay. The GWP is 1430, 1430. So a great replacement for 134A, probably the best retrofit gas most people have ever seen is R513A. GWP is 573. You literally don't have to change anything. We're going to recommend an oil change to POEL, but you don't necessarily have to. But read the guidelines, go to the Opteon training page and look up 513. It'll give you step by step. But this is a great refrigerant to replace those medium temp applications, those reach-in coolers that have 134A in them. When it comes to the air conditioning side of the cars, the automobile industry, we're going to be moving to R1234YF, okay, GWP of around less than 1. Okay, and that depends on what scale you're using, whether it's a 100-year scale or something else. Okay, but that is actually in every car made and manufactured in the United States, sold. In fact, most of the world, to be honest with you. So it's a smaller charge, very small charge, great refrigerant. Okay, now it can't be used in larger charge systems, but it does play a big role moving forward in blends and has been for some time. Now, over here to the air conditioning chiller heat pumps, we do not have anything to replace 410A, nor do we have anything to replace R32. So your options are going to be pretty simple with the new equipment. All right. There's no retrofit gas at this time for either one of these. So R32 is still being used. It's less than that 700, 675, and then we'll have 454B in new equipment. So you'll either have to use virgin 410A or reclaimed 410A when they come back from the reclaimers, once they start getting more of that. All right. So in new equipment, less than 700, that'll be 454B, 467. As of right now, all OEMs have chosen R454B except Daikin. They've went with R32, and they have some skin in the game with that. And anything Daikin owns, like Goodman or Amana. Okay. Now, Opteon, this is for your chillers. Some of your chillers will be 454C, and that's a GWP of 146. All right. Refrigerant options and key recommendations for existing 404A systems, R22, 407, and 507 systems. We're going to retrofit to R449A. This is a great gas. You also have the option of doing R448A, pardon me, and existing systems for 134A systems, as we talked about earlier, you're going to retrofit to 513A. XP10, Opteon XP10. This is a great refrigerant. Like I said earlier, make no bones about it. This is probably the best retrofit gas that I personally have ever seen, and a lot of engineers agree with me. Now, new systems under 200 pounds, 404A-like performance will be 454A, and it's a 90% reduction in GWP. That's 3,922 versus 238. That's a big deal. All right. New systems over 200 pounds, or we're going to go with 454C or XL20 Opteon. That's A2L refrigerants. All right. That's a big reduction. Now, I noted down here 50 pounds of charge or less needs to be 150 GWP in California and New York at this time when this is being recorded. Let's take a look at this. I really like this slide. It really tells a big story. Okay. So replacing 404A, we have one tank of gas here for 404A. This is based on the GWP. In comparison, when we retrofit to 449A, we have three tanks equal of one tank based on its GWP. Okay. And when we move into the new equipment, 454C, we can make all this virgin refrigerant compared to the same GWP we were doing with one tank of 404A virgin. Okay. You can see even retrofit is a big, big savings on the GWP. You can use three of this compared to one of 404A. So 404A, as you saw earlier, almost 4,000 GWP. It's on the chopping block pretty fast. Okay. Because the reason for that is because again, you only have so much in your bucket you can fill up. If you make a lot of 404A, has a very high GWP, you're using up a lot of your allocations. And if I can make all of this compared to one of these, I'm going to make a lot of this and a lot of this, right? Okay. 1 pound of R4 404A is the equivalent of 3 pounds of 449A and 26 pounds of 454C. So what's an HFO? Let's talk about that. An HFO. Let's go through some refrigerant chemistry. Now, I'm not a chemist, but I understand this. We had CFCs, okay, Montreal Protocol. That would have been like our R12s, chlorofluorocarbons. HCFCs, hydrochlorofluorocarbons, less ozone depletion. This would be like good old R22. And then they start to notice that hole in the ozone and they're taking precautions and they connected it to this C at the beginning here, which stands for the chlorine. So they removed that and we went to HFCs, hydrofluorocarbons. And that is not ozone depletion because there's no C there in the beginning, right? And we now moving from HFCs because of the GWP or global warming potential, we're going to HFOs. And an HFO, simple analogy is really it's an HFC in disguise. And what I mean by that is the definition of olefin is these two carbon atoms double bonded next to each other. If you put your hand over one of these, technically or closely, this is really an HFC molecule. What the chemists found out years ago was in the labs was when they connected these two carbon atoms, double bonded them, that when they're exposed higher up in the atmosphere, they become very brittle and they break up really fast. Okay, really, really fast compared to an HFC molecule. The double bond in the HFO molecule breaks down much quicker in the atmosphere. So that's really why we're having this conversation today, quite honestly. It's most cases, it's going to do equal capacity or better than. But it's going to break up a lot faster so that it's going to disperse that atmosphere, that bubble, if you will, a little quicker. So let's compare two refrigerants. 134A used in medium temp coolers, reach-ins, and those kind of things for your pop, your beer, and bologna and those kind of things. And then we have 1234IF used in the automobile and a lot of blends. About every blend that's coming out now. It's even in R449A, and it's been there for a while. So this is also used in the automobile industry. 134A by itself, as we all know. And now this one's taken over the R1234YF. But what are we really saying? This here stays in the atmosphere for approximately 13 years. This stays in the atmosphere for approximately 10 days. That's why we're having this conversation. GWP of 1430, GWP of either 1 or 4, less than, depending on what chart you're using, whether you're using a 100-year chart or 20-year chart or whatever chart you're using, okay? Because they're all numbered differently, a 4 and a 5 and what have you, okay? But here's what I really like as a technician. Are you really losing anything? Here's our gauges, really, right? We got pressure here, temperature here, and that's really what it is, a pressure temperature chart. And that's really what we're looking at on our gauges, saturation and our pressures, right? So look at this. The blue line is showing 134A. The red line running very, very close is 1234IF. It's not until we get up into those higher temperatures and those higher pressures that they start to break away a little bit. That's what I'm saying. 1234F is a great refrigerant, but it can't be really a standalone refrigerant in those larger charge systems. All right. So, so let's talk about lower flammability, specifically A2L refrigerants, because that's what they are. There's highly flammable, lower flame, and then no flame. So when they do this testing, what they do is they put the refrigerant in a glass flask or a tube, if you will, and they add just the right amount of air. I've actually been to the chambers myself up at the Chemours headquarters. And what they're doing is they have a magnetic stirring mechanism down here at the bottom. And obviously, we learned in HVAC 101 in our first year, we need air, we need some kind of concentration of refrigerant, and we need something to ignite it. So they're sitting outside the lab room and the chambers, and they're watching this. And right when it hits right the perfect LFL, they hit the electrodes and it ignites. Now, the reason of this picture here is if it ignites and the flame stays within this 90 degrees, or V as in Victor, if you will, it's considered non-flammable, a 1 classification. All right. The A stands for the toxicity, but I'll get into that a little bit later. Okay. If it breaks that line, that 90 degrees, or that V as in Victor, if you will, it's then considered flammable. And then it's just a matter of how flammable it is. Okay. So this is the refrigerants we're used to using. This could be 404A. This is actually 410A, by the way. Stayed inside the lines here, inside the V. All right, we're good to go. Stamp it. Let's move on. When they tested A2L refrigerants, specifically 454B, they saw this. And you can see how it just broke the line. Now, I'm not trying to play this down, but now the chemists are scratching their heads because they've never seen anything this close to what we're already using. But this 90 degree has a lot of chemistry and a lot of formula to it. There's a reason if it breaks that it has to be classified. So we've used it for years and we can't move the goalpost. Okay. So now it's flammable. It's just a matter of how flammable it is. If we were looking at an A2 classification, for example, that's considered flammable, all right, it would be around the 9 and 3 o'clock position if I had a picture of it, but I don't. All right. But this is what you see at A3. This is propane. So that's a lot more exciting morning at the water cooler when we light that. All right. Big difference. This is what we're accustomed to. Almost all the refrigerants we've used in our legacy systems for years and years and years. This is what we're moving to in most systems, applications, and A2L. So it was so close to what we resembled, they had to make a new classification for. This classification is brand new to the US and fairly new, to be honest with you, the face of the earth. Okay. And again, the first letter is your toxicity, and the second digit is the number is the flammability. The higher the number, the higher the flammability. Okay. A is just stands for low or no toxicity. I like to say low because anything with enough parts per million will asphyxiate you. All right. So let's take this relationship between flammability and GWP. I want to compare 404A to 454A. First of all, in order to lower the global warming potential, we have to get rid of the chemicals that are causing that inside these blends. Unfortunately, some of those chemicals was what was making them non-flammable. For example, 404A, 134A, 44% 125, and 52% 143A. 125, if you didn't know that, is what we use in almost every fire extinguisher made today. But it has a very high GWP. When you remove that and come over here and make our 454A A2L refrigerant, we have a global warming potential of 238 compared to 3922. And what's in it? What are the components? Well, we have 65% R32 and we have 35% of 1234F. And when it comes to the 454A, B, and C, these are the same components in every one of those refrigerants. They just change the ratio depending on what they want the SST to be, your evaporator suction saturation temperature. Okay, what do we want? How low do we want to go, basically? Okay. On the right over here is showing you the new kid on the block, if you will, A2Ls, lower flammability. The higher these go up, the higher the flammability, the higher the number. The left or right is the toxicity. A, let's think as good or and B as in bad, if you will. So ammonia has been used since the turn of the century. It's always been a B2. Well, when this A2L classification came along, the ammonia folks looked at this and said, well, if that's an A2L, then we should be a B2L. And now, fun fact, ammonia is classified as a B2L. And that refrigerant, again, has been around since the turn of the century. All right. So we've got 152A as your example of the A2. We have propane as the example of A3. Here's our R454A and C as the A2Ls. And then we've got the A1s, the 404As. All right. Let's look at the Opteon refrigerants, the A2L refrigerants. We're going to be talking mainly about R454A and C. Close up with 454A, it meets regulatory requirements. It's SNAP 26 listed with use in conditions. Okay, and SNAP is just another arm of the EPA. Basically, it has to do with the applications. And by the way, there's a QR code here. Watch for these QR codes throughout my presentation, the training video here. They'll take you right to all this information. It's lower flammability, A2L designation, similar equipment design to 404A, POE oil, low and medium temp refrigeration applications. Okay, again, here's that blend. 1234IF and R32. And this stays the same in A, B, and C. You can see the ratio here for the 454A is 65% 32 and then 35% of 1234IF. Remember that 1234IF has a very, very low GWP and has good capacity as long as it's not trying to hold a large charge by itself. So you blend that in with the R32, still getting good capacity and lowers that GWP. So what does it look like on paper? Let's look at it. Here's your ASHRAE number, 404A, 449A, and 454A. So I'm talking about existing equipment, what we can retrofit, because not all these systems are going to go away, right? We can't afford to rip them all out and put new equipment in. They're going to be out there for a while. Some of those compressors, like the Copeland reciprocating compressors, last a long time. And all my refrigerant buddies out there know this. R449, I've used it many, many times. It will replace the 404A. And you saw what the difference is in GWP compared to 404A. This will be for new equipment and new equipment only. So we're going to start with the relative capacity. And relative, if you didn't know, whenever you see the word relative, that just means our starting point or our baseline. So we're going to be comparing everything to 404A. That will be given the number 1. Okay. When it comes to retrofitting 449A and capacity, you're losing nothing. It's equivalent. When we get the new equipment, the capacity is going to be 1.07 with 454A. All right. So you're actually gaining capacity on that. Let's look at relative COP. Again, relative 404A will be an example where we're comparing it to. That just means baseline or 100%. So it's 1.00 compared to 1.06 with 449A. And so you're actually gaining COP. And then on the new equipment, it's 1.05. So you're gaining COP on this. Now, what is COP? For those of you who don't know. Well, it stands for coefficient of performance, but in the Don Gillis version or definition, I'm going to say it like this. It's simply put, it's how much capacity you're getting out of your evaporator compared to how much energy you're using on your compressor or the system as a whole. So it takes the capacity and the energy used in the system as a whole and puts it into the ratio. This is the important number they use like for equipment designers. The COP is everything them. That's kind of what they start with, all right? And then everything else follows behind it. Relative mass flow, starting at 1, then we go to 0.76 for 449A and 0.72 for new equipment, 454A. Suction pressures. Now this is PSIA. Don't let that confuse you. We always use PSIG. PSIA, simply put, is your gauge pressure, PSIG, with atmospheric pressure or standard atmospheric pressure added to it, which we typically say is what? 14.7. Some people round it up to 15. You're simply adding that 15 to your gauge pressure, whatever you're seeing on your gauges, whether they're digital or the old mercury gauges. All right. So with that said, suction is 30.9 in 404A on the low side. Suction for 449A will be 26.6. And then on the new equipment will be 29.4. So not a big difference there. Now on the discharge pressures, again, this is PSI-A, not to make a big deal out of it. If you're seeing 267 on the high side, you'll see 258 on the 449A, and then 270.6 on the R454A. And again, this is absolute. So if it was gauge pressure, you would just think in your head minus around 15 or 14.7. Discharge temperatures, this is 6 inches out from the compressor. We're always focused on that. We never want it to be over the 225 mark if we can help it. All right. If it is designed to run over 225 degrees Fahrenheit, you can bet yourself that it has some kind of OEM thermistor or some way to read temperature just beyond that 6 inches. And that's when we start to see our liquid and vapor injections. All right. So 6 inches out from 404A, we typically on a good running system is around 173. Now, don't hold me to this. It's not sketched in stone, but this is what it looks like in the labs. For 449A, it would be approximately around 206.8. And then for the new equipment, 454A will be somewhere around 211. All right. So GWP for 448 is 239 versus 33,988. Come up here and look. Opteon XL40 performance, closest performance match to 404A with a GWP of less than 300. It's higher efficiency than 404A, and it's a close pressure match as we talked about. Now, for 454A charge considerations, under 200-pound charge per circuit in the USA, best suited for condensing units. Now, when you use these in condensing units, you're going to have, and I'll get into this later, what releasable charge means. You're only going to be allowed a 4.90 pound releasable charge for partial units with doors, and I would even throw drawers in there. So doors and drawers. Systems condensing units without doors and drawers, open cases, releasable charge will be 7.97 for obvious reasons. If you can't trap the gas, they're going to allow you a little more releasable charge. And again, I'll explain releasable charge here in a little bit. Now, up to 159.3 pounds of releasable charge for walk-in coolers and freezers. That's going to depend on your area dependent. What that means is cubic feet. All right. And I'll show you that here in a little bit. But first, I want to compare 454C. Again, it meets all the regulatory requirements, as we talked about earlier, similar equipment design requirements, POE oil, lower and medium temp refrigeration, in some cases, AC and heat pumps. So this is going to be for systems over 200 pounds, first and foremost, all right? The performance considerations, capacity, delta due to 150 GWP requirement, higher efficiency than 404A. And well, let's just look at that, all right? Here again is our relative capacity. We know relative is going to stand for our baseline, our comparison. We're going to compare 404A again with 449A and 454C. So here's our baseline is 1. 449 didn't change, obviously. It's going to stay the same. So if you're retrofitting that, it's a very easy retrofit, by the way. And then on the new equipment, you're going to lose a little bit of capacity down to 0.89. But hold the phone. When it comes to relative COP, which is, in my opinion, the biggest number on here, the most important, we're going to have 1 here. You're going to gain again 1.06 on 449A, and you're also going to gain on the new equipment for 1.06. So as a whole, as far as the equipment, emissions, and what have you, you're going to actually gain on the COP, the coefficients of performance. Relative mass flow, 1.76, and then 0.80. Suction pressure, 30.9, 26.6. Compared to 24.3 on your new equipment. Now, remember, this is only going to be used in new equipment designed for A2L refrigerants. And you can see what we're doing in the pressures and the suction pressures and the discharge pressure, and then our temperatures on our 6 inches out from our compressor. Okay. So we're actually going down lower here on our temperature than we would 449A, which wasn't the case earlier, 192.1. All right. So new terms to consider when working with A2Ls in commercial refrigeration: lower flame limit, or LFL. Um, that is your releasable charge. We're going to talk about what that means to you, and then mitigation strategies. Okay. So let's talk about this. The first step: lower flame limit. What does that mean to you? Charge sizes for A2L equipment and commercial refrigeration are typically a multiplier of the lower flammability limit. So just to bring you up to par here, what LFL means: there's a lower flame limit and there's an upper flame limit. Okay. And until it hits the lower flame limit, can't even become flammable. In other words, that flask we were talking about earlier, where we were adding the concentration of the refrigerant and the air, and then hitting that electrodes or some way to ignite it, okay, it's not even flammable until it hits LFL. All right, so this is the lower flame limit. So what are the requirements? Some examples for cases with doors and drawers: again, it's 8 times LFL. So in the case of 454C, that would be 5.1 pounds of 454C. All right. Cases without doors or drawers will have 13 times LFL, somewhere around 8.3 pounds for 454C. Now, walk-in coolers up to 260 times LFL, and for 454C, it's approximately 166.4 pounds. Now, if you don't know what that little squiggly mark, it simply means somewhere thereabouts, or nominal, if you will. The second part: releasable charge. Standalone equipment that is factory charged and sealed, uses the total charge multipliers. It cannot take advantage of the concept of a releasable charge. All right. So if it's standalone, charged from the factory, it cannot take advantage of the releasable charge. For partial units, i.e. field-directed equipment, the multiplier of the charge limit is not based on total charge, but rather releasable charge. And I'll explain what that means here in a little bit. To have a releasable charge, you need 2 new pieces of part of that equipment. You need some type of leak detection built in the system, and then some type of safety shutoffs, whether that be a solenoid valve or a check valve or something like that. Okay. The releasable charge is determined by the total amount of refrigerant that can be released within the safety shutoff valves. So, and that's going to be based on volume of cubic feet and different factors. The third part is mitigation strategies. 3 main mitigations. First of all, room volume, cubic feet. And then 2, will we need air circulation? And then 3, will we need also mechanical ventilation? In some cases, you'll need air circulation and mechanical ventilation. When we say air circulation, all that's saying is kicking on the fans of the evaporator if there is a leak, to lessen that concentration in one space. But mechanical ventilation is literally either removing the air, bringing fresh air in, and we'll walk through that one by one. So, need to ask yourself, is my releasable charge large enough where I need additional safety controls such as air circulation and or ventilation? If a charge size is large enough to need additional mitigations, other options could be possible, such as smaller circuits, so more lines, more evaporators. Critical for walk-in cooler freezers, compressor units, and condensing units. Cases are always, let me repeat that, cases are always the multiplier of the LFL. So 8 times doors and drawers, 13 times open cases. All right. Now let's take a look at your typical walk-in cooler. Let's walk through this scenario. Here's our box. Here's our sensor inside there. Obviously our evaporator. Here's our storage right there. So we're walking in cooler right there. Okay, you can see our refrigerant lines coming in and leaving. All right. So the scenario is this: we get a leak. The refrigerant leak occurs. The sensor picks it up. Mitigation is activated. All right. And this mitigation strategy, we have a releasable charge is in between the 2 valves. So in other words, when it senses the leak, the mitigation is activated. It could be one of 2 things, okay? First thing we're going to do, though, in these walk-in cooler type applications, we're going to shut this down. The solenoid's going to come closed. the check valve's in place so nothing can come back in there. This, between these two inside here, is what's considered releasable charge. And that's dependent on how much of that is dependent on what type of application is, as we talked about earlier. All right. Is it, uh, or are you just going to need the evaporator fans to kick on for moving air? Or are we going to need to bring fresh air or move air in? That's going to depend on the strategy. So let's take a look at the next slide. So this is really busy, obviously. All right. Um, a lot's going on here, but let's start with the y axis, which is up and down here, and then we'll go to the x axis that's horizontally down here. The y axis is charge per pounds. As we move up, we're higher in the charge per pounds, or the pounds of charge. Left to right, we're getting more cubic feet. So the more cubic feet we get, the more charge we'd be allowed to have, or the less of mitigation strategies. So let's look at it like this, all right? Pardon me, I lost my mouse. So inside this blue area up here, if anything over this way with this amount of charge and this amount of cubic feet right here is out of compliance. All right. If you move over here to this, you could be in compliance. All right. But it depends on what you're going to need to be. But right here in this area, and if you stop and think about it, this is really, really a low charge. I mean, or a low cubic feet. They're really talking about a very small area if you were inside that blue, the non-compliant space. All right. And if you think about it, like I said, that's a very tiny room with a lot of charge. And the reason that is out of compliance is simply this. Because if you were to have a leak, the refrigerant in the small volume, the risk is higher, which would be a safety concern, obviously. Now, this triangle area here needs air circulation, but no ventilation. So this is way down here with a small charge, but a very small area. So inside this triangle area, that would fall into, we're going to turn the evaporator fans on and move some air, but we wouldn't need ventilation, either removing or bringing in. All right. So that's the second one. So let's look at it a little further here. And the reason we're moving that circulation, as I said earlier, in case there's a leak, you would move that concentration and lessen it. Now, up here under the blue line, the top right, you would need air circulation and ventilation. Think about it here. We've got lots of pounds in the charge. The charge is quite high. We have a lot of room up here, but the charge is such to where we're going to have air circulation and ventilation. Pardon me. Okay, and the perfect place, the sweet spot where we want to be is right here. Okay, this is the sweet spot of it. Anything below this yellow area here, so we don't have that much charge, and we've got quite a bit of cubic feet right here. All right, so the only thing you would need there is room volume. All right, that would be just the room volume and room volume only. So that would be that mitigation strategy. Think about it. That is a mitigation strategy. If there's enough cubic feet of air there, you don't have to worry as much about these other safety features as far as bringing in, circulating air or bringing in fresh air or some type of ventilation. Okay. Again, the two features you're going to need there are going to be your sensors and your safety device. You're going to need something to sense it, as we showed in that walk-in cooler diagram. And then we're also going to need some kind of shutoffs, relief or check valves and solenoid valves. Any releasable charge under the yellow line does not require ventilation or air circulation. All right, right here. Sorry, I had the wrong area. This is just based on the room volume. It's everyday business. Let's talk about the service trucks. What's changing there? Well, service vehicles under the materials of trade, it's really business as usual. And what I mean by that is we've always had a restriction in place of 440 pounds maximum, regardless of the hazard. I mean, it could bend 440 pounds in separate tanks of acetylene, all right, which is much more flammable than A2Ls. So that's kind of a breath of fresh air that they didn't lower that for the A2L refrigerants, all right? Now, federally, on the service vans, these are all for the service vans, there are no placards required for service vehicles, all right? No placards. And also, another myth buster, no ventilation required. So if you heard that, it's simply not true. It's not required, all right, for A2L refrigerants. And last but not least, this was the big one for a long time. A2L tanks will be able to lay on horizontally on their side. Okay, they were thinking that they wanted them vertically originally because they wanted a vapor barrier between the tank laying up vertically and the liquid up against the ruptured disc or the relief valve going to be on the new tanks. All right. Chemours did a lot of testing and sent it to the DOT, and it passed with flying colors. All right. So you will be able to lay them on the horizontal. Now, the company you're buying from, the refrigerant, has had to apply for this permit that Chemours got for the industry. You know, was given. It's a DOT SP 21513. All right. So this is just a copy of what that actually looks like. Now, you're not carrying this permit with you in your truck. This number will be stamped on the tank collar along with a QR code, but it's proof in this training video that you can lay them on the side as long as the refrigerant you're using applied for this permit number. Safely using A2Ls in the field. So some of the things you're going to see on the tank changes is this. You're going to have a red stripe around the tanks. They're going away from colors, first of all. They didn't want an A1 refrigerant with a green and come in with an A2L refrigerant slightly off green. They were running out of colors, really, to someone to grab the wrong one. So they decided to go to you might call it a gray. Some people are going to call it an off-white, whatever you would call it. Okay, you're either going to see on the bigger tanks, it's going to look something like this on your 90 pounders. On the smaller DACs, you're going to have the gray body with a red stripe. You also are going to go have left-handed threads. So this will be for the smaller DAC, the 1/4-inch male adapter. All right, it's going to change it back to right-hand threads. So if you knowingly see this tank with a red stripe around it and you knowingly put this left-hand adapter on there, you're knowingly breaking the law by the EPA, okay? Because you're putting a refrigerant, A2L refrigerant, in a system that's not designed for it, okay? So you do not want to put 454B in an existing R410A system or anything with 454A or C in an existing system for like 404A. All right. Here's the adapter for the larger tanks, by the way. Again, it's just an adapter. It comes with left-hand threads. This will turn it back into right-hand threads. Okay. It's just think of it as a pause button or a speed bump, if you will. Okay. It makes that new technician, if they don't know, and you know as well as I do, every day there's thousands of new technicians. I see them all the time as much as I travel, and they're out there. And like it or not, a lot of those technicians, like it was when I was in the field, I've been doing this for 35 years now. I spent 25 years in a service truck. Okay. People are being moved from preventive maintenance to service literally overnight. And why is that? Well, they're 50 calls behind. We've all been there, and it's 90 plus degrees out, and everybody's complaining. The food's getting spoiled. Mrs. Jones doesn't have air. The baby's hot, whatever that might be. Okay. Now, moving forward, also, you're going to see a different safety device. We've always had ruptured disc in the past, and I'll explain this on the next slide. So, we've always had ruptured disc. How do ruptured disc works? Gets above that pressure temperature that's allowed for that refrigerant tank. This pops and blows the whole charge. Now, where I'm at, that's never happened. Very rarely, if ever. Okay. Now, down in Arizona, I can't speak for them, or down in the southern states, I hear say from people that are older than I that it's happened once or twice in their industry. But you have to the storage has always been set for like 130 or 125 less than. Okay, so you have to take that in consideration. All right, the ruptured disc is considered a CG1 for A1 refrigerants, and it releases the entire contents of the tank. Moving forward, for more peace of mind for the A2L refrigerants, it's going to have a CG7. Think of it as a spring-loaded device or a relief valve, if you will. And it's going to release just enough to lower the pressure. So in other words, my definition is it's going to burp. It's going to burp and it's going to release just enough charge to take it back to the specifications where it's safety is, and it's going to shut back up. By the way, this was not required. All right, this is something the tank manufacturers and companies like Chemours wanted to do for safety to ease people's minds. And these type of safety features have been on the larger tanks for years, so it's not really new to us in the industry. Let's talk about tools. Now, first of all, moving forward, don't buy anything that's not A2L compatible or compliant or rated or tested or however they word it. It's an excellent time to upgrade and make the switch to A2L rated tools and test instruments. The top priority is keeping yourself and customers safe when using mild frame refrigerants. Okay. That does not mean that everything in your truck today is not A2L approved. All right. You need to do a little homework. What I've been suggesting to everyone, go look at the manufacturer's website. They're doing a great job of having these little A2L buttons on there, and you click on it, look for the model number you recently have, okay, even if it doesn't say A2L, and see if it's A2L approved. Because in some cases, the tools are not changing. They've just been tested now, and they're allowed to put A2L compliant. For example, this G-Twin over here, okay, they don't make new recovery machines every year like they do new cars. There's not a new model of these, and a lot of times every year. So the model 5 years ago might be the latest and greatest. Not in all cases, but in some cases, all right? Now, in some cases, there are changes. You'll see a lot more brushless motors moving forward. You'll see things cased differently with the contactors or anything to do with any kind of switches and what have you, and those kind of things. So I don't want to mislead you, but don't go out and buy all new tools for your trucks because it's more than likely not needed, especially with hand tools, obviously. But do your homework, go to the wholesaler, check with the people that sold you the tools and find out, am I good or am I not good? Again, same thing here. Now, personally, I would replace hoses for A2L refrigerants, and I would have a completely different gauge setup for A2L refrigerants. Just like supermarket guys, like we used to do, is you're going to have multiple hoses for supermarkets because they get into so many different cases. You don't have to purge all the time, or you still purge your hoses, but you know what I'm saying. It lessens the chance of contamination, cross contamination. So let's look at some things we're familiar with, some flammable stuff, the substances, and what it takes to ignite it. It's referred to MIE, or minimum ignition energies, and it's done in millijoules. And the way this works is the less the number, the greater the flammability. So methane, for example, is a 0.47. Propane, R290, is a 0.25. And by the way, if you're not familiar with 290 as a refrigerant, that's why we get a little disappointed when people think that there's propane in A2L refrigerants. There's not. It's not something flammable they added. It's like I showed you earlier, that R125. It's what they removed that was keeping it from being flammable before. And that R125, as I mentioned earlier, is found in fire extinguishers, almost all fire extinguishers, actually. So it was, and the way that works is when it hits the air or exposed to air, it sucks the oxygen out of the air immediately, causing it not to be able to be flammable. So that's a fun fact there. Here's another fun fact. R290 is the same flammability, the propane that we use in our gas grills or furnaces or whatever you use it for. However, in order for it to be pure enough to use as a refrigerant, you can't put the stench in it. In other words, it doesn't have a smell. So that's a whole different ballgame with that, okay? I mean, like right now, when this training video is being made, the most you can have is 150 grams. Or that comes out to about 5.2 ounces or somewhere thereabouts. Okay. So again, the lower the number, the higher the flammability. 454B, I just threw one out there. Example is somewhere around 300. So that's a far cry from propane. Gasoline, even higher than propane. It's a 0.2. All right. And then diesel fuel is a 20. And here's some of the things third party, not Chemours, but third party people and multiple third parties have tested. And imagine like a plexiglass box, if you will. all right, in the right amount of cubic feet or the area with the substances we have over here, all right. Now they tested these tools with A2L refrigerants, nothing else. I'm only speaking of this, and this is based on the MIE. So when it comes to the household object or the job site objects, A2 ignition sources, we're talking about cigarette insertions, barbecue lighters, light switches, hand mixers, cordless drills, friction spark, hair dryer, toaster, hot plate. Now you probably wouldn't have a hot plate on the job site, but you may have. I don't know. But this is really kind of saying, in all seriousness, is if you've got a ducted system, for example, remember the mitigation strategies. You have that sensor. It's going to kick on the air, the fan, or G, if you will, for you technicians out there. And then it's going to lessen the concentration or in and around that evaporator. All right. So that has the potential of blowing in the house. Well, the sensors for, let's say, like comfort cooling, residential, like commercial, the UL required it to go off at 25%, no greater than 25% of LFL. And until it hits LFL, it's not even flammable. So these sensors are set way lower than the LFL. All right. So just remember that. In fact, for residential air conditionings, what I'm seeing from most OEMs is somewhere between 20% down to 12%. And they all have slightly different strategies. All right. So it's going to be the same way for commercial. Some of the resources I'm going to offer you here. This is going to be, you can find this on the AHR website. Just put it in the Google machine, AHRI, A2L, Safety Equipment Task Force, Best Practices, or take advantage of this QR code I just generated right before I did this training video. All right. It walks you through everything line by line of how the AHRI Safety Task Handling Task Force would like you to do it. All right. Safety first. Here's your A2L installation. Here's your evacuation. Here's your charging. If you need to charge, A2L system repairs, and A2L recovery practices. All right. So great piece of literature here. Again, if you go to this website, you can literally download the PDF. And that's what you're looking at right now. This is nothing more than the PDF that I downloaded from their website and put it on this PowerPoint slide. Another fun thing, if you're on the wholesaler side, or if you store a lot of refrigerant, if you're that big of a company, here's a pamphlet, colored just like it is. I took this PDF and literally put it on this PowerPoint, and it talks about A2L cylinder storage options. Now, this is not enforced yet out in our local jurisdictions or municipalities. Okay, it's not down to the state or county or municipalities yet. This is the guideline that's set by the AHRI of storage for A2L cylinders. All right, you can use this QR code. It'll take you right to this pamphlet, and you can use it on your PowerPoint slides. But it tells you everything about the type of steel you would need, the material, and how you can stack it and how far you can stack it. So you got self storage, rack storage, and then solid piles where you're actually putting the refrigerant on top of each other. And it tells you how much you can go up. It tells you the occupancy classification, whether it's mercantile, storage warehouse, or a factory filling facility, sprinklers, and tells you when you need all that stuff. So a lot of good information going on here. I'm not going to read it all to you. It's kind of an eye chart, but you can get it for free. Go to their website or just scan this QR code if you're watching this training on your computer. Here's another nice little fun fact. You can now go to the AHRI building code map, A2L building code map. You can just Google it. I actually have this on my home screen on my phone, and I send this PDF out when people text me, email me, or ask me, hey, I'm in such and such county in such and such state. Where are we at with all this stuff? At the beginning of this, it was hard to follow because we hadn't had the AIM Act fully operational in all the states. So everybody was kind of doing their own thing, and we were watching CARB and what have you. But now we have everybody pretty much on board, if you will. There are some variances in certain states, but for the most part, somewhere, somehow, A2L refrigerants are allowed in different areas, all right, or most of the nation. So you come over here and you pick your state out. They chose Maryland, and when you pick the state out, it's going to highlight like this. But what's really neat about this is in the state of Maryland, in real time, whether it's Ohio, Indiana, California, Louisiana, whatever, or Louisiana, it's going to tell you in real time your legislation passed, effective date, AC codes, all right, refrigerant codes, warehouse codes, and state codes for the warehousing. Here's all your standards, your ASHRAE 15, your ASHRAE 34, your UL 2-40, and UL 2-89. Now, some of Chemours resources that I want to share with you are going to be our training page, but it's not just a training page. You'll be seeing videos like this training video on our webpage. We already have a lot of videos. Dr. Chuck, check up with Dr. Chuck. I believe he's in his 7th season, I believe. These are 4 to 8 minute videos, kind of like did you know, fun facts, easy to digest between your service calls. Great information. Basically, small sections of the things I just talked about for an hour. All right, great. Check out this Dr. Chuck. You can go right to the website using this QR code, or just go to option.com training page and you can go right there. You'll see all this stuff here. Here's a picture of myself, but you'll have all the training down below. I mean, literature, all kinds of stuff. I mean, everything you think. Also, our tech support. You'll find Bobby here, Bobby Dean, one of my coworkers back at tech support. He's the main guy back there. Here's the email address, tech2tech@chemours.com, 1-800 number. All right, tech to tech. Contact us for support. And then you can go there and also opt into our global content quarterly magazine. If you don't like it, it's free, delete it. I would encourage you to get that. So every quarter, you'll get this flyer kind of updating you on what's going on. And as I said earlier, all kinds of literature, and not just this kind of stuff. I mean, I'm talking about, the PDFs on, each refrigerants, step-by-step applications for changing out R449 to a 404A existing systems, PT charts. Everything's in color and it's all free. Okay, so check out our website for more information and useful resources. You can follow us on YouTube, option.com YouTube, Facebook, and LinkedIn. All right. That's all I have for you. I hope you got something out of this. If you want to scan the QR code, this will give you a training certificate for the training today. All right. I hope you liked it. Please put in the area of the training evaluation what you would have liked to seen.